Hello everyone, this is Mr. Slomka again. This is going to be video number 2 of 5 that is going to be about creating the unit circle. Our first video was a little introduction, and this one is going to kind of work towards filling our unit circle in with some good information. So let's take a look. The unit circle is once again going to be our very special tool that is going to help us find a lot of great exact values for sine and cosine values in the near future. So it's not a punishment, it's not a memorization exercise, it is a tool. And so we want to build our tool so that we can use our tool. So right now we're going to be building our tool. So some things that we saw in our first video was we were using a circle with a very special radius, and the radius that we're going to be working with is going to be a radius of 1 unit. As I had mentioned earlier, this tool that we're going to be using is called something called the unit circle, and the reason that it's called the unit circle is because it has a radius of 1 unit. That unit could be a foot or a mile or an inch or a nanometer or a light year, but it has to be 1 unit. Next, all of the angles. Last time in my first video, I had shown you a very unpopular angle measure of 75 degrees, but all of the angles that I want to put on the unit circle from here on out are going to be some very popular, very special angles that are going to come from the special triangles. So all of that information that you learned about 30, 60, 90, 45, 45, 90, pi over 4, pi over 4, pi over 2, pi over 3, and pi over 6 are all going to come into play right here. And the last piece, the thing we learned from our first video, is that if we want to know about cosine and sine values, we can find them very quickly and easily, because every x value for our angle measures on our unit circle is going to be a cosine value, and every y value for our angle measures on our unit circle is going to be a sine value. So that is fantastic information. Okay, so now let's start filling some things in. So to begin with, the first thing that we need to do is we are going to be creating our unit circle, and we need to fill it in with the most popular angle measures. So these angle measures are going to be based off of our 2 special triangles. One of our special triangles is the 45, 45, 90 triangle. And so what we need is we need to write down all of the angles that will exist in a circle that are related to that. So let me show you. Our first angle that we're going to pick is 0. That one's very straightforward and easy. Then our next angle that we're going to choose is when we rotate counterclockwise 45 degrees. So we're going to have that guy right there. Now what I want to do is I want to keep rotating by increments of 45 degrees until I return right back to where I started. So if I rotate another 45 degrees, that gets me to 90 degrees. If I rotate another 45 degrees after that, I'm going to be up to 135 degrees. Another 45 is going to get me to 180 degrees, 225 degrees, 270 degrees, 315 degrees, and then if you add 45 one more time, you end up at the exact same place where you started, and that is 360 degrees. So not only does the 45, 45, 90 triangle give you these piece of information and this piece of information, but it also provides you with all of these ones. They're all connected to the same 45, 45, 90 triangle. So we're going to want to use all of these. Similar to that, but slightly different, over here what I want to do is I want to get some information about the 30, 60, 90 triangle. So let's see if we can do that. So the first one right here, this very small rotation, you'll notice it's less than the rotation we use for the 45, is going to be 30 degrees. So this is our 30-degree rotation right here. If we add 30 degrees more, that is going to get us up to 60 degrees. If we add 30 again, we're up to 90 degrees. So this is all the information that we usually find on the triangle, but I want to once again continue. So I want to keep on adding 30 degrees each time. So now what we're going to do is we're going to bump up to 120 degrees. We're going to bump up to 150 degrees, 180 degrees. So I've added 30 degrees each time. Let's keep going though. 210 degrees, 240 degrees, and 270 degrees. There we go. Last couple. I want to keep on adding 30 degrees, and that's going to get me to 300, 330, and then lastly 360, has you end up right where you start. So all of this information is going to be extremely important to have, and I want to make sure that my tool, my unit circle, includes all of these angles, and all of these angles are going to be extremely important. So I want to make sure that my circle is going to include all of them as well. Once again, a circle is an extremely efficient tool because you can cram a lot of information in a small area. Let me show you that a little bit more. So right down here, what I have is, you'll notice that I have only a small portion of a circle, or a quadrant of a circle. I have the upper right-hand region of the circle right here. And what I want you to see right here is that I have crammed in not only the 30-degree angle, but I also have the 45-degree angle. I have the 60-degree angle as well, and I have the 90-degree angle and the 0-degree angle as well. So they're all here. They're all crammed together. But it's very nicely organized. Nothing is overlapping or touching, and it looks very, very nice. So that works out well. So now what I also had talked to you about is I also would love to have these points along the outer edge. In our first video, we had talked about how each of these points is not only an ordered pair for the location of the dot, but it also happens to deal very, very closely with the cosine and the sine of the angle measures that we've been writing down. So it would be extremely helpful to have this information. Now, luckily for us, to get this information right here, we don't need to use our calculator because we have special triangles. And so I have our two special triangles right over here. These are the exact same way that they've always looked. They're never going to change. So once again, try to get these kind of tucked away into your brain because they are extremely useful and beneficial. And every time that you need them, you're going to want to try to pull them out of your long-term memory. So let's see if we can use these triangles right here to figure out some of these ordered pairs. Last time we were doing one of these, what I had done is I had actually counted my tick marks and I had kind of eyeballed it. I don't want to do that same thing again. What I do want to do is I want to try to use my special triangles here. So let me show you what I'm talking about. So this first one that I'm taking a look at right here, this is my 30-degree angle. If I wanted to be more specific, what I could do here is I could drop a vertical line down from my 30-degree angle right here. And if you take a look at what I've created, now what I've built for you is I've built a small triangle, and it's a very special triangle. It is actually a 30-degree triangle with a 30-degree angle and a 90-degree angle, and that makes it our nice special triangle right here. If I want to know the cosine value of my special triangle, I just need to remember how to find a cosine. And so I'm going to use my good old trick, SOHCAHTOA, in order to do that. Cosine means adjacent over hypotenuse. So if I want to find the cosine for this triangle right down here, I'm going to use all of the information from this triangle right over here. I am going to use my adjacent side and my hypotenuse, and it's going to build the fraction for me, √3/2. So that is going to be my cosine value right there. You can do the exact same thing for the sine. So the second number that's going to go right here would be the sine of this small triangle that I've created right here. And so sine is SO, which is going to be opposite over hypotenuse. So instead of working on this triangle, I'm going to come over here and I'm going to be working on this triangle right over here. And opposite over hypotenuse means I'm going to be using the 1/2. And so that is going to be right here. Let's just check to make sure that our answer seems reasonable. I want to make sure that my first answer for my x value is bigger because that distance is very long. I want to make sure that the answer for my y value is smaller because that distance is very short. And you'll see right here that our fractions definitely meet that. √3/2 is an improper fraction, which means, not an improper fraction. It is a larger fraction, I should say. And 1/2 right here is a smaller fraction. So that meets our criteria and it works out very nicely. Let's do the same thing for 45 degrees. So now, once again, for 45 degrees, what I can do here is this line right here represents our 45-degree rotation. If I add on another line, a vertical line that drops down to the x-axis, what I'm going to have here is another special triangle. This special triangle is a 45-45-90 special triangle. And because of that, if I want to know about the cosine or the sine of that angle, I can use this special triangle right over here. 45-45-90s are great because they have these matching sides right here. So let's do cosine first. Cosine is always going to be first. That's nice. It's like alphabetical order. C comes first in the alphabet and S comes much later. So we're always going to do cosine first and then we'll do sine later. So let's do that. So I'm going to be able to pick between either of these 45s. I'm going to pick the lower one because I like it. It looks more like what I have over here. And cosine is adjacent first, so I'm going to do adjacent over my hypotenuse, which is going to give me 1/√2. Now, I would love to write down 1/√2 in here, but I happen to know that 1/√2 is a little bit not so great. The problem here is that the cosine of 45 is 1 over root 2, and you're not allowed to have a square root in the denominator. So in order to get rid of the square root that's in the denominator, we are going to have to rationalize it. That's a big fancy word, and I hope that you can use that often. Rationalizing means you get rid of the square root in the denominator, but you keep the number. So when we rationalize, we're going to end up with a root 2 in the numerator now, but root 2 times root 2 in the denominator just gives us a nice 2, so that's wonderful. We're going to end up with root 2 over 2. Now let's talk about sine. Sine is opposite over hypotenuse. And so if I go back to this triangle, I'm going to use opposite over hypotenuse this time. Opposite on this problem is the exact same as the adjacent was. So I'm going to also end up with the sine of 45 being 1 over root 2. Now this one also needs to get rationalized. So we're going to be multiplying by our root 2's, and we're going to end up with the exact same answer. Next, let's do cos 60. So 60 right here is our third one. And so 60 is going to be, once again, this line right here represents our 60-degree angle. It's a rotation from the x-axis. If I drop another vertical line down through here, what you'll see is that I'm actually building myself a right triangle. And it happens to be a special right triangle. It's a 30, 60, 90 special right triangle. So what I want to do here is I want to know the cosine and the sine for that 60-degree angle. So instead of doing it on the circle right here, I'm going to come over here. I'm going to use this 60-degree angle, and I'm going to find the cosine of this. So now cosine of 60 right over here. Cosine of 60 is pretty great. It's going to be my adjacent over my hypotenuse. So that's going to be 1 over 2. Excellent. Wonderful. Now, that's interesting, though, because if you remember, that was actually the sine of 30 right over there. We had used the opposite over hypotenuse, but now since we're switching angles, that is now the adjacent over the hypotenuse. Then also, I want to do the sine of 60. That means we're going to do opposite over hypotenuse. Opposite over hypotenuse means it's going to be root 3 over 2. Wonderful. So this is the majority of the important information that we need on our special unit circle tool. There are a couple of extras right here that you might notice that I've forgotten, and these are actually super, super easy, and they're so easy that we don't need to use our unit circle for them. So that's fantastic. Let me show you what we're going to do for these guys. So now these ones you might notice would be very difficult to draw a triangle for this guy right up here because it's just a vertical line. Same thing over here. It would be hard to draw a triangle for this one right over here, so we don't have to. All we need to do in order to fill in the ordered pairs for these guys right here is remember the first thing we wrote down. We had written down that our circle has a radius of 1. So if we are starting here at the origin, which is going to be the point 0, 0, and we want to travel directly to the side, we don't want to travel up or down at all, we just want to travel directly to the side, and we know that we're going to be traveling a distance of 1 unit, that means that the ordered pair right here has got to be 1, 0. The 1 means we traveled to the right 1. The 0 means we did not travel up or down at all. Similarly, but slightly different, up here at the top of the page, this guy means that we need to travel exactly 1 unit, but we need to do it vertically, not side to side at all. So this time what we would do is we would choose 0, 1. Excellent. So now this is going to be video number 2. I want you to notice that we're collecting things for our tool. So far we've collected all of our degree values, and now what we're doing is we're starting to collect some of our ordered pairs, which are going to represent our cosine and our sine values. I'm going to make a third video next that is going to give us our last element of the tool, and then the fourth video is going to put it all together.